Hi, this is my video number 24. I'll talk on ratio test, and another one is NP test. Okay, for this video, right? For the ratio test, we have a limit n goes to infinity, un. Yeah? This is equal to some number rows. Okay, first case, if row is less than 1, then this series converge. Alright, and number 2, if row is greater than 1, then that series diverge. And if row equal to 1 is inconclusive, that series no conclusion can be made. No conclusion can be made means we don't know whether the series converge or diverge. You remember that the purpose is still that we want to determine that series converge or diverge. All this while we talk about convergence and divergence of the series. We have couple of tests. You need to know those things. Comparison tests 1 and 2. We have what else? Integral test. We have ratio test. Or this time, this is not ratio test. This is a root test actually. Root test. ROOT. Root test. Ratio test we have. I have given in the previous video. Now let's see some example. Before that, all these tests we use when test one after another fail to give the required conclusion. Okay, if let's say the comparison test cannot give any decision on whether series converge or diverge, then we go to the second comparison test. If it still cannot, then we can use the ratio test and integral test and root test and so on and so forth. But looking at the given sequence or given series, we should be able to guess which test shall we use. Okay? And if we use a comparison test, which series must be chosen in order to determine the given series either converge or diverge. Now look at this test, root test. The definition is that the limit of root n of un, if you take that limit, is equal to something. Then if row is less than 1, then the series converge. If row greater than 1, it might goes to infinity. Row could goes to infinity, then un diverge. And if that row equal to 1, then again no conclusion can be made. Okay, I give you some example. Let's see a simple case first. Let's consider this example. N over 2n plus 1 to the power n. Now we want to determine whether this series converge or diverge. If you use ratio test, one of the hints to use the ratio test is that look at the power here. Okay, you look at the power here, then we know that the appropriate test can we use is ratio test. Okay, if you use the ratio test, we take a limit. N goes to infinity. Root of n root n over 2n plus 1 to the power n. Okay, so that you can write this, you can write that as a limit n 2n plus 1 to the n to the half, the 1 over n. Alright, that you can cancel out. That give you limit n over 2n plus 1. That give you half. Yeah, n goes to infinity everywhere. N goes to infinity. So that gives you half. So this is less than 1. So therefore this series converge. N over 2n plus 1 to the n converge. Okay. So let's consider other example. I'll give you this example. So let's say un is given as this, n over 2n for n odd, and 1 over 2 to the n for n even. Okay. So remember that this is the series that we want to test, diverge or converge, where un is given as that. Okay, if you use a ratio test, root test, we take a n root of un, so what we have now, this is n root of that, so we have n to the that's n to the 1 over n, that's over 2, yeah, because n and 1 over n cancel out, so we have 2, and the other one you have 1 over 2. So you can see from there that our series is in between half and half, that, and those things, n to the 1 over n over 2. Since I think you can check this thing, just a minute. Okay, since n, you take a limit, this thing, limit n goes to 1, I can write this limit n 1 over n goes to infinity, so this goes to 1. It's not difficult to see this. You look at this n, when n goes to infinity, that 1 over n goes to 0, so n to the power of 0, you got 1. So it's not difficult to see that. Okay, so therefore we have that part is going to 1, that part, if you take a limit of this, limit on the left side is half, on right hand side that goes to 1, so we get half. Alright, so therefore limit of n un, this is equal to half, which is less than 1, so therefore our series converge. Okay, do you understand? You look at here, left hand side, if you take a limit half, we got half. We take a limit this one, this is the one that we want to determine. On the right hand side, you take a limit of this, that one is goes to 1, so on the right hand side we got 1 over 2, so left hand side 1 over 2, right hand side 1 over 2, so therefore the limit of un is 1 over 2. We can use sandwich theorem. Yeah, sandwich theorem. You know what sandwich theorem is? Yeah, sandwich theorem means if the right converts to some numbers, right hand side converts to the same numbers, then in the middle also goes converts to the same number. So therefore that's converge. Okay, you may try this. Okay, do this as an exercise. You try this. If you have number one, if you have a series of n to the 10 over 10 to the 10, n to n. Okay, it's not difficult. And number two, you can try this 2 to the n over n to 2. Alright, so there's a root test. Now look at another test that we call NP test. NP test. Okay. For NP test, so we let UN is our series with UN positive. We will deal with a positive such that limit of NP UN is equal to L. Okay, and goes to infinity. Then this series converge if P greater than 1 and L is finite. Yeah, finite means you have some numbers. It cannot go to infinity. Alright. And number two, UN diverge if P less than 1 and L different than 0. Okay? Let's say example. Let's consider this. N over 2n cubed plus 1. Okay? Well, you might think of, maybe we can try, is it a particular test for a particular series? We must use a particular test? Not necessarily. Sometimes it's work for a couple of tests. Yeah, maybe it's work for a comparison test and probably for other tests as well. Yeah, it's not unique. The test is not unique. Okay, so let's try this. If you take this limit of n goes to infinity, okay, we use NP test, where NP test is n to the power of p un. So n to the power of p, what choice of p that we need to use? Now here we have n to the power of p. We need to choose p here, and our sequence is our series is n over 2n cubed plus 1. So for this case, you look at the denominator, the highest power is 3. Alright, so if we have here n 3s, then we can cancel out with that, and then we can take a limit easily. So in order to have that, we choose p equal to 2. Okay, if you simplify this, so what we have, this is limit n goes to infinity, then n cubed over 2n cubed plus 1, that give you half. Okay, half, if you look at this, we have p greater than 1. In our case, our p is 2, and L, which is the limit of those expression, is finite. So in our case, it's half is a finite. It's different than 0. Alright, it's finite. So therefore those series n cubed plus 1 converge. Okay, now you can try this. I leave it to you as an exercise. Let's say this ln n over n plus 1. Number 2, let's say we have sine cube 1 over n. I think for this case as well as this case, you can choose for this case you can choose p equal to half, I guess. P equal to half. For this case you can choose p equal to 3. P equal to 3. Yeah. Then I think you can do that. For this case, I give a okay. Let me do this one. For this one, number 2, right? For this one, number 2. So we take a limit, n goes to infinity. If we take p equal to 3, so we have n3 sine 3 1 over n. I can write this as a limit that sine 1 over n, everything here to the power of 3, and this thing here is actually 1 over, right? So 1 over n to the power of 3. Okay, and this for n big enough, so it means the inside the bracket here becomes very small. For small argument of sine, yeah, for small argument of sine, sine a is just about a, for a small, okay, remember this. For a small, sine a just about a, for a small. For that, because of that, so if this is just limit n goes to infinity, so look at this. If n goes to infinity, if n is big enough, okay, n is big enough, so sine 1 over something big, so the argument is very very small, so that's it, just give whatever the argument is. So we have 1 over n to the 3 over 1 over n to the 3, yeah, that give you 1. Yeah, so in this case, look at our test. N, our p is 3, our L is 1, our L is 1, which is finite. So therefore that series sine 3 1 over n converge. Oh, like that. Okay, so I think I stop here for this video. Next I'll talk on the alternate series. Okay, bye bye.